They might seem easy at first, but when we find puzzles like this one, they tend to be struggling. So I was wondering, how can we solve this puzzle only using exponents and logarithms? By the way, I got this puzzle off GMAT Club. You should go check them out. They have some pretty good puzzles. Okay, so what we can do with this 5 to the power of 10x is we can write this as a logarithm as log base 5 4,900, and then we have is equal to 10x. Okay, now we can just divide both sides by 10 to get that x is equal to log base 5 of 4,900 divided by 10. Okay, now let's have a look at y. So we can do the same logic. Log base 2 of 25 is equal to square root of y. Okay, I think we're pretty good and pretty set. Now the thing is, this log base 2 here is a little bit annoying when we want to plug it into this base of 4 here with this power of square root with the minus square root of y. So how are we going to do this? We have to go back to this 2 to the power of square root of y is equal to 25. Let's square both sides. So we get 2 to the power of square root of y times 2 is equal to 625. So we can rewrite this as 2 to the power of 2 in brackets to the square root of y. We know this because of this property called a to the power of b to the power of c is equal to a to the c to the power of b. Okay, so we know that's equal to 625. So this is just equivalent to 4. So we can write this as a log base 4 of 625 is equal to square root of y. Okay, let's have a look at this puzzle again. So we can write this as 5 to the power of x minus 1 all to the power 5 divided by, when we have a negative exponent, we know that this is equal to 1 over x to the y. So we can rewrite this as 1 over 4 to the y, square root of y power. So then we can times top and bottom by 4 to the power square root of y to get that this will give us 4 to the power of square root of y times this whole thing here will just give us our answer. Okay, now let's do the final substitutions. We have square root of y is equal to this thing. So when we have x to the log of x and then a, this will just give us a. So when we have 5 to the x minus 1, this is the same as 5 to the x divided by 5. So let's plug it in. We have 5 to the log base 5 of, let's see, 4,900, and then we have that all divided by 5. Oh, and this is divided by 10. Okay, so we can write this 10 outside. So we have 5 to the power of log base 5 4,900, and then we can write 1 divided by 10 outside, and then we have that all divided by 5. And don't forget, this is to the power of 5 in our question. Okay, so we know that this will give us 4,900. So we have 4,900, and it's to the 10th root. So we know that this is 5th root of 70, and then we have that divided by 5, and then we're going to have that in all to the 5th power. So we know that this square root of 5 and 5 will cancel. So we get 70 divided by 5 to the 5th power, which is 3,125. Okay, now that we have the top part, we're going to times it by 4 to the square root of y power. So we have 4 to the square root of y power, which we know is log base 4 of 625. Okay, this will just give us 625. Oh wow. So we have 70 divided by 3,125 times 625. So we can write this 70 divided by 3,125. We can divide both sides by 5. 70 divided by 5 is 14. And then we have 3,125 divided by 5 give us 625. And then we have that times 625. Ha! Look at that! Our top and bottom cancel. So we just get 14. So 14 is our answer.